In this lesson, we'll use our knowledge to solve right triangles to work some application problems. We'll start off by looking at a problem. The directions usually say solve the problem. A guy wire 43 6/10 meters long is attached to the top of a pole that is 34 2/10 meters high. Find the angle that the wire makes with the ground. Well, I think it helps to sketch the triangle. We will assume that the pole is perpendicular to the ground, forming a right angle. So this will represent my pole. Here's my right angle. This will represent my guy wire, and of course that's where it's attached to the ground, and this will be my ground. So it tells me that the guy wire is 43 6/10 meters. So let's label that. And it tells me how tall my pole is. If this is my pole, then I know that this distance is 34.2 meters, and I'm asked to find the angle that the wire makes with the ground. Now, that would be this angle right here. I will call this angle A. You can call it whatever you want to. Of course, we call the right angle angle C. But usually when I'm solving one of these application problems, I don't worry about labeling everything. What I worry about is I have been given two pieces of information, and I'm supposed to find this angle A. So what I have to do is I have to look at what I'm trying to find, angle A, and see how it relates to these two pieces of information I'm given. Well, this side, this leg, is the leg opposite angle A, and of course the 43.6 is the hypotenuse. So which trig function do I know for angle A that uses opposite and hypotenuse? And that would be the sine function, wouldn't it? So what I do is I set up my equation. The sine of A equals, and then it's equal to the length of the opposite leg, which is 34.2, divided by the length of the hypotenuse, which is 43.6. So then I want to calculate that on my calculator. Now, I'm going to use a scientific calculator, and when I do, I enter the 34.2 divided by the 43.6, and then I push the equals to get it to divide, and anytime I'm looking for the angle when I have the value of the trig function, I'm going to use that second function button, and on most calculators it's a second function. Sometimes it's called something else, and in this case it's my sine, which of course when I use that second function button before the sine, that represents the inverse sine function, which is written on your calculator above the button. So let's see what we get when we do that. And what we get when we do that is this number, and of course it keeps on going, and your number may be a little different depending on how your calculator is set to round. Now this is an angle, and they didn't tell me whether I should write this angle in decimal degrees or whether I should write this angle in degrees and minutes. And usually when they leave it up to me, then I choose what's the easier to do, which it's easier to leave it in decimal degrees. So let's decide where we need to round. Well, let's look at this. You see how they gave us those sides for 3 significant digits? Well, remember when you're rounding an angle to 3 significant digits and you're using decimal degrees, then you want to use this round to the nearest tenth. So we will look at the hundredths place. Since that's a 2, that tells us just to leave the 9 in the tenths place, and of course we drop all the rest of these digits. So our angle A would equal 5 9/10 degrees. Now, I didn't mention that your calculator should be in degree mode, but obviously if you want that angle in degree mode, and for right triangle trig you do want that angle in degrees, then your calculator needs to be in degree mode. We'll assume for this lesson that we want any angles to be in degrees, and I won't mention anymore that the calculator needs to be in degree mode. You just remember that, okay? Let's look at another problem. Find the altitude of an isosceles triangle having a base of 65 10/100 centimeters if the angle opposite the base is 64 degrees 26 minutes. Now, what do they mean by an isosceles triangle? That means that 2 of the sides are equal. And what they've given us is the base side. So let's draw that. Okay, let's see if I can make it look like these sides are equal. All right, does it look like this side is equal to that side? Now, they tell me that the base, which would be this side, is 65 10/100 centimeters long, and they tell me the angle opposite the base, which would be that angle right there, is 64 degrees 26 minutes. Now they ask me to find the altitude. What is the altitude? Well, it is the line that bisects the angle opposite the base, and it also bisects the base, forming a right angle. So I think what we'll do here, they're asking us to find the length of that. Usually we call it the height of the triangle, so I think I'll just call it H in this case, but I think I'll draw this smaller right triangle so we can just focus on that, where we know we're looking for H. But what do we know about this triangle? Well, first of all, since the altitude bisects this angle, we know that this little angle right here is half of this angle. So what we want to do is figure out what half of this angle is. Well, divide 2 into 64, and it goes 32 times, so it would be 32 degrees, and then divide 2 into the 26 minutes, and it is 13 minutes. So this angle right here would measure 32 degrees 13 minutes. And the other thing we need is the length of this leg right here, which, since that altitude bisects that base, it will be half of 65.10. So just take this 65.10 and divide it by 2, and we find that the length of this leg is 32.55 centimeters, and of course, since this is 4 significant digits. We want that to equal 4 significant digits. Now, we want to find this leg. This would be the hypotenuse of this right triangle because it would be across from the right angle. We're given this leg and we want to find this leg, and of course we know this angle. So let's relate what we know. We've got this angle. This side is the leg opposite that angle, and this H that we're looking for is the leg that is adjacent to that angle. So which function uses opposite and adjacent for this angle? It's the tangent function, isn't it? So let's set up our equation. The tangent of 32 degrees, 13 minutes equals the length of the opposite side, which is 32 and 5,500 centimeters, divided by the length of the adjacent side, which is H. Now we want to solve this for H. And let me remind you of something. We want to completely do our algebra manipulation before we calculate anything, so that when we get ready to figure out what H is, we'll completely enter our calculations in our calculator and come up with one value, and at that time we will round. So let's look at this. To solve for H, since it's in the denominator, I want to multiply both sides of my equation by H. Those H's cancel. On the left side, I have H times the tangent of 32 degrees, 13 minutes equals 32.55. Now to get H by itself, since it's been multiplied by this quantity, remember this quantity just represents a number, and I can manipulate that number just like I would manipulate any number. So to undo this multiplication, I will divide both sides by this tangent. Of course, those divide to 1, and so my H equals 32.55 divided by the tangent of 32 degrees, 13 minutes. Now, I'll have to be careful on my calculator to convert 32 degrees, 13 minutes to decimal degrees, because that's how my calculator likes it. So, using a scientific calculator, I will first put in the 32.55 divided by, and then I need to calculate this tangent. Now, because I'm using a scientific calculator, I'll have to put my angle in first, and because I want to convert it to decimal degrees, I'm going to use my parentheses. Remember, if your calculator has a shortcut way to convert degrees and minutes to decimal degrees, use it. But all the calculators will convert by saying parentheses 32 plus the 13 divided by 60, because there are 60 minutes in a degree, close parentheses, and then if I want to find the tangent of that angle, I just push my tangent button and push your equals to get it to actually do that division. So let's calculate that. what I get in my calculator is 51.655 something. So let's see. I don't really need all those digits, so I don't think I'll write them. What do I need to round to, and what tells me what I need to round to? Well, look how many digits, significant digits, they gave me for this side, and also look at the significant digits for this angle. Degrees and minutes, when it's to the nearest minute, that's 4, and also here it's obviously 4 significant digits. So I want 4 significant digits, which means I want to round to this place right here. Since there's a 5 in the thousandths place, I will add 1 to the hundredths place. So rounded for H, and I probably should put approximately, shouldn't I, which means that I have rounded. It would equal 51.66 centimeters. So that would be the height of that triangle. The next problem that we work involves angle of elevation. So I'd like to begin by defining an angle of elevation. For angle of elevation, we are always talking about from a point below to a point above. Now this may be a point on the ground. This may be the top of a tree, the top of a cliff. It could be the sun. But it's important to keep in mind we are always talking about something below to something above. And we relate that angle to the horizontal. If this was the ground, this would be considered the horizontal. We define the angle of elevation from point X to point Y. That's important. From here to here as the acute angle formed by the ray X, Y, and a horizontal ray with endpoint at X. So here's your horizontal ray, there's your ray X, Y, and so this would represent the angle of elevation. Now sometimes we refer to this ray X, Y as the line of sight. But at any rate, it would be the line from point X to point Y. So let's look at a problem. The shadow of a vertical tower is 24 6/10 meters long when the angle of elevation of the sun is 28 6/10 degrees. Find the height of the tower. Well, let's draw this. Here's my tower. We will assume that the tower is perpendicular to the ground. So this will represent my ground. And let's go ahead and form our right triangle. Now, if this is my tower, and we'll pretend like my sun's up here. If this is my tower, then its shadow will be represented by this length right here. And what they tell us the length of the shadow is, let's see, the shadow of a vertical tower is 24 6/10 meters long when the angle of elevation of the sun, well, that would be the angle created right here. It would be the angle between the horizontal and this line that goes from this point on the ground up to the top of the tower. So we know that that angle is 28.6 degrees, and what they want us to do is to find the height of this tower, which I'll call H. So let's look at these two parts given and what we're looking for, and let's see how this relates. For this angle, H is the opposite leg. 24.6 is the adjacent leg. So the function that we'll use is the tangent of the angle. We'll say the tangent of 28.6 degrees equals the length of h divided by h, which is the opposite leg, divided by the length of the adjacent leg, which is 24.6. We'll solve this equation for h by multiplying both sides of the equation by 24.6. Those will divide out. We're left with h equals 24.6, and I think I'll use parentheses, times the tangent of 28.6 degrees. And so what we need to do is just multiply the 24.6 times the tangent of 28.6 degrees. And you can just say 24.6. On my scientific calculator, I'll say 24.6 times, and on my scientific I have to enter my angle first, 28.6, push the tangent, and then push the equals, and that'll do the multiplication for us. And we get 13.4 something. What do we need to round to? Well, this is 3 significant digits, and that's 3 significant digits. So let's round to 3 significant digits. It would be 13.4. And what would the measure be? It would equal meters, wouldn't it? Now let's look at another definition. This is the definition of the angle of depression. For the angle of depression, we're always talking about a physical situation where we're going from something above to something below. At this point, maybe we're a plane in the sky looking at a point on the ground. Maybe we're at the top of the building looking at a point on the ground. Maybe we're at the top of a tree looking at a point on the ground. The angle of depression from point X to point Y, and what's important is you start at point X and you're looking at something below point X, is the acute angle formed by the ray XY. This ray, or you can call that the line of sight, or just think of it as the line between X and Y, and a horizontal ray with endpoint at X. The horizontal ray is what we call whatever would be horizontal, meaning that it would be parallel to the ground down here. So the angle of depression is this angle right there, the angle created between this line that would be up here with point A but parallel to the ground, and the line that would run, or the ray that would run from point X to point Y. The angle of depression from the top of a cliff to a point on the ground is 25 degrees 50 minutes. How far is the point on the ground from the bottom of the cliff if the cliff is 198 meters high? Well, once again, let's draw it. And this is going to represent my cliff. So right here is where we're talking about the top of the cliff. We're going to imagine that the cliff is perpendicular to the ground, and here's that point on the ground. And there's the top of the cliff. And let's show our right angle, and let's connect those 2 points. Top of the cliff, and there's the ground. Let's see what it tells me. It says the angle of depression from the top of a cliff to a point on the ground is 25 degrees 50 minutes. Now, which angle is that? Well, it's the angle between this line and the horizontal. Now, the horizontal would be the line up here at the top of the cliff that was parallel to the ground. So there's your horizontal. There's the line between the top of the cliff and the point on the ground. So it's this angle right here that's 25 degrees 50 minutes. Now let's see what else I know. We want to know how far is the point on the ground from the bottom of the cliff. So that would be this distance right here. I'm just going to call that distance little a. That would be one of the legs of the right triangle. So I'll just call it A. And what else does it tell me? It tells me the cliff is 198 meters high. So I know that this distance is 198 meters. Now, I know that that forms a right angle, just like this forms a right angle. Since this is perpendicular to the ground and the ground is parallel to this horizontal, then it will also be perpendicular. But I think it's easier at this point to use our knowledge about transversals. Imagine you've got a line there. Imagine that this extends, that this is parallel, and look at the line that connects the top of the cliff to the ground. Look at that as a line, and that forms a transversal. And what do we know about this angle and this angle? What do we call those? Those are alternate interior angles, and we know that they are equal. So if I know this angle is 25 degrees 50 minutes, then I know that this angle down here is also 25 degrees 50 minutes. And I won't write it inside right there because it won't fit. So let's use our knowledge that this is 25 degrees 50 minutes. This leg is opposite this angle. This leg is adjacent to this angle. So we'll use the tangent function. We'll say the tangent of 25 degrees 50 minutes equals the length of the opposite leg, which is 198 meters, divided by the length of the adjacent leg, which is A. Now, if we want to solve this for A, we first have to clear A out of the denominator, so we'll multiply both sides of the equation by A. The A's over here divide to 1, so we'll have on the left side A times the tangent of 25 degrees 50 minutes equals 198. Now, to undo multiplying A by the tangent of 25 degrees 50 minutes, we want to divide both sides of this equation by that. I don't really have enough room to do that, do I? So I'm going to rewrite it down here so I won't have to mess it up too much. Now let's divide. I think I'll have enough room to do that over here. Both sides by that tangent those, of course, divide to 1. So when I get ready to calculate what A is equal to 198 divided by the tangent of 25 degrees 50 minutes. Since this is in degrees and minutes, when I put it in my calculator, I will need to convert degrees and minutes to decimal degrees, however you do that. On my scientific, I would say 198 divided by, and of course I'll have to put my angle in first, and to convert, I'll say 25 plus 50 divided by 60 close parentheses, and then I want to find the tangent, so I'll push my tangent button, and then I'll need to push my equals to get it to divide for me. So let's see what we get. And I got 408.975, and let's see, maybe I don't have a really good place to write it, but let me see if I can write it right here. I want you to. And it keeps on going, but you can certainly tell if you've got it right. Now let's talk about what we want to round to. The side was given to me 3 significant digits, and of course this angle is 3 significant digits, so I need to round to 3 significant digits. Well, for this number, the 0, since it's between the 4 and the 8, is considered significant. Zeros on the end or on the beginning are not considered significant unless they have decimals and have zeros. So what I need to do is to round to this place right here. Since that's a 9, that tells me to round up, so I'll add 1. So in this case, my A is equal to 409, and 409 what? Well, this is a side, isn't it? And my sides would all be measured using the same measure, so this would be 409 meters. Let's look at one last problem that involves both the angle of elevation and the angle of depression. The angle of elevation from the top of a small building to the top of a nearby taller building is 42 degrees 30 minutes, while the angle of depression to the bottom is 15 degrees 20 minutes. Find the height of the taller building if the smaller building is 23 meters high. Well, let's draw a sketch. Now, I don't know that I've mentioned this, but I hope that you realize that when we draw a sketch, it is certainly not true to scale. What we try to do is just kind of get the angles and the sides in the right place, and we would really have to have a protractor and something to measure with to draw it true to scale. So I'm just going to put a smaller building up here. This will be my smaller building, and I'm going to draw a taller building. And I think I'll draw my ground down here, and that will sort of help me. And now let's figure out where this angle of elevation is. The angle of elevation from the top of the small building to the top of the nearby taller building is 42 degrees 30 minutes. Well, let's draw the line that connects those 2 points. And remember that angle of elevation is the angle between this line and the horizontal. So I'm going to do a dotted line here to represent the horizontal of this point at the top of the smaller building. So I know this angle right here, that angle, is 42 degrees 30 minutes. Now let's see where this 15 degree 20 minute angle is, while the angle of depression to the bottom is 15 degrees 20 minutes. Well, that means the angle of depression from the point at the top of the smaller building to this point at the bottom of the taller building. And so let's draw the line that connects them. And of course the angle of depression is between this line and the horizontal with this point up here. So we're talking about this angle right here. maybe I'll label it over here. Have pretty many things to label, don't I? 15 degrees, 20 minutes, and I know we're talking about that angle right there. Now the other thing is, I want to find the height of the building, and I'm just going to put it over here. This is what I'm trying to find, and I know that the height of the smaller building is 23 meters. So I know this height is 23 meters. Well, that kind of helps me, doesn't it? Let's see here. Do you see that I have a right triangle formed here? And then I have a second right triangle formed here. And I actually know what the length of this leg is, don't I? Isn't this the same as the height of that smaller building? So this distance from there to there is 23 meters. Okay? Well, now look at this bottom triangle. I know this angle and this side. But for this top triangle, I only know this angle. Well, they're asking me to find this height. Well, this height is obviously this 23 meters plus whatever this height is right here. So what I've got to find for this problem is this distance right here, which is one of the legs for this upper triangle. Of course, this would be the hypotenuse across from the right angle. This would represent a leg. That would represent a leg. So I'm going to call that H, and so I need to find H. The problem is with this upper triangle, I'm finding H, and the only thing I know besides the right angle is this acute angle right here. So I don't really have enough information to find anything. But look at this bottom triangle. I know it's a right triangle because it has that right angle, and I know this angle and one of the legs. And any time that I know one acute angle and one side, then I can find any of the other parts of a right triangle. Well, which part would help me to find? Well, if I could find this distance right here, then I would know an angle and a side in this triangle, and I could find H. So that's what I'll do. And you can call this side whatever you would like to. I'm just going to call it A. So this will be from here to here will represent side A. Side A is adjacent to my angle that I know right here. And the 23 meters is opposite the angle I know. So I can say that the tangent of my 15 degrees 20 minutes is equal to the length of the opposite leg, which is 23, divided by the length of the adjacent leg, which is A. And so to solve for A, we'll multiply both sides of the equation by A. These will divide to 1, and we're left with A times the tangent of 15 degrees 20 minutes equals 23, and then of course to undo multiplying A by the tangent of 15 degrees 20 minutes, we'll divide both sides by 15 degrees 20 minutes. So that divides to 1, and to find side A, we will take our 23 and we'll divide it by the tangent of 15 degrees 20 minutes. Now, we have actually worked several problems like that in this lesson, so if you don't remember how to calculate it, you might want to rewind to one of the other problems that we worked. And here's what I got for side A. Side A, let's see, is 83.88207428. What do we want to round to? Well, the height of the smaller building was given to us in 3 significant digits, and both our angles are 3 significant. So to 3 significant digits, I've got 83.88. I'm only concerned with this 8. Since it is an 8, that tells me to add 1. So my approximation for A would be 83.9, and those would be meters. So now I know this side right here. Now I'm going to redraw only the top triangle. And let's see, that top triangle looks something like this. And I'm looking for this side, which is H. I have found that this leg is 83 9/10 meters. And I know that this angle is 42 degrees 30 minutes. So to find H, H is opposite my angle. 83 9/10 is adjacent to my angle. So once again, I will use the tangent function. The tangent of 42 degrees 30 minutes equals H divided by 83 9/10. To solve for H, I will multiply both sides by 83 9/10. Those divide to 1, and H is equal to 83 9/10 multiplied by the tangent of 42 degrees 30 minutes. And once again, in this lesson, we've done several calculations like that. So if you have forgotten how to do that, look back at one of those other problems. And so I get H, this leg, is equal to, and I want to round to 3 significant digits. I have 76.88 something, and since that's an 8, I will add 1. So my H is 76.9 meters. And don't forget, with your calculations for your 42 degrees 30 minutes, you've got to change it to decimal degrees, just like, of course, for 15 degrees 20 minutes, you had to convert it to decimal degrees when you calculated it, when you put it in your calculator. Now, is that the answer to the question? What was the question? Well, what I was supposed to do was to find the height of the taller building, wasn't I? Well, I found what H was. I found that this height right here was 76.9 meters, but that's just this little part right here. What do I have to do to get the whole height of the building? Well, I have to add this 23 meters, and you can see obviously this is not drawn to scale. If it were, that's much larger than that, and that should be much taller. So that's just an example of how inaccurate our sketches can be. To find the height of that taller building, what will I need to do? I'll need to add this to that. So let's do that. Let's see here. We will say 76 9/10 meters. We will add that to the 23 meters, which of course was given to us as 0.0. And we will get that that building is 99 9/10 meters high. That completes this lesson. If you're finished with the tape, please rewind it. Thank you.